The topic of this problem is Kirchhoff's current law. And we're going to use Kirchhoff's current law to determine I sub x in the circuit that is drawn below. Before we start the problem, let's restate what Kirchhoff's current law is. It is the algebraic sum of the currents entering any node at any instant in time is 0. So the first thing we do when we're solving problems using Kirchhoff's current law is we identify the nodes. And the nodes in this problem are at the top. We have one node at the top which connects the elements. We have one node at the bottom which connects the elements. So we can use Kirchhoff's current law at either one of these nodes. And in fact, we can either sum the currents into the node or we can sum the currents out of the node in order to find I sub x. So in this instance, let's sum the currents out of the node at the top. So we're doing KCL out of the top node. So we're going to let's go ahead and do that. So if we look at the leftmost part of the circuit, we see that I sub x is flowing out, and it's a positive I sub x flowing out. We have 10 I sub x flowing in, so it's a minus 10 I sub x from the current-controlled current source. It's a dependent source in the circuit. We also have 120 milliamp independent source, which is flowing out, so it's going to be a positive since we're taking the currents which are flowing out. And we also have 12 milliamps flowing upward into the top node through the rightmost resistor. So it's going to be a minus 12 milliamps. And so that's equal to 0. So we have an equation which has only one unknown associated with it. It's I sub x. So if we solve for I sub x in this problem, then we end up with an I sub x equal to 12 milliamps.